So students, we will start the first chapter of physics in standard 9 NCERT book, that is motion. So in this chapter we will study about different things, but in this video what we will cover, first is rest and motion, about rest and motion, distance and displacement, uniform and non-uniform motion, speed, velocity. This much we will cover in this video. So now we will see what is this rest and what is this motion. In our day-to-day life, this rest and motion, or motion only, if you will see, we can observe by some direct events, such as when a car is moving. It is direct event. We can see that car and we can tell that the car is in motion. Direct event, moving of or movement of car. Movement of car. If you will see car is moving, then you can find. Okay. You can see when you are running. You can see that child that you are in motion. If a child is running, you can tell the child is in motion. If a statue is there and it is not moving, that is direct event. You can see that and you can tell that it is that rest. Also, sometimes to express motion, we need to observe some indirect events, such as the motion type of motion is revolution of earth. Revolution of earth. You cannot observe it, you cannot feel it, revolution of earth, because you are on earth, but you are feeling that you are at rest, but the earth is moving around the sun. But how to know that that revolution of earth? By observing the seasons. Events are seasons, like seasons. Rotation of earth, directly you cannot notice rotation, but by taking the day and night, you can feel the rotation is happening. So these are some direct events, these are some indirect events where you can feel that how motion is happening. So if you will go to definition directly, rest and motion, then already you have studied, if an object is changing its position, with respect to its immediate surrounding, then the object is said to be in motion. Then what is rest? If the object is not changing its position or doesn't change its position with respect to its immediate surrounding, then the object is said to be at rest. So this is basically about rest and motion. In this rest and motion, in previous classes you have studied about this definition. From here we can get another concept, that is point of reference. What is this immediate surrounding? You have to take one point of reference. One example. When a train is moving from the platform, then you have to take some point of reference to express whether it is at rest or in motion. Like the train is moving, train is in motion, with respect to platform, Okay, the train is in motion with respect to platform. If two trains are moving at same speed, two trains are moving in a same speed. Otherwise, you can take example, you and your friend are sitting in the train. Then you can tell, I am at rest with respect to my friend. So this with respect to this particular point, this is called as point of reference. With respect to the platform, with respect to my friend, these are point of reference. Another thing is there, motion is relative. Motion is always relative. How? The same example if you will take. A person is standing at the platform and you and your friend are sitting inside the train. Then you can tell you are at rest with respect to your friend, but you are in motion with respect to that person in the platform. So you are in motion, you are in rest. In both the sentences, in motion, in rest. That's why by taking this point of reference, you can tell that motion is relative. You can find here that motion is relative. So this is about rest and motion. Already you have studied all these things in previous classes. So remember what is motion, it will be helping you. Next things, after rest and motion, distance and displacement. Distance and displacement. Distance and displacement. So first is distance. What is distance? If you are covering a path, if you are traveling by cycle in a road, so the length of the path covered by an object is called distance. For example, you started from this point to this point in this road, and this is 5 kilometers. Then the distance traveled by you is 5 kilometers or not? Yes, this is distance. Next we will come displacement. Displacement is the shortest path between initial point and final point of the object is called displacement. Like this shortest, what is the shortest path here in between A and B? The straight line distance. If you will draw the straight line distance, this is the shortest path between the initial. You have started from here, initial point. You have started here, you have made the end here. That is the final point. So the straight path between the 2 points, or initial and final point, or the shortest path, is called displacement. If it is, let it is 3 kilometers. Then the displacement is 3 kilometers between A and B. Another example we will take here. This is point P. You have travelled from point P to Q. It is 4 kilometers. Then Q to R. It is 7 kilometers. Let. Then you have started from P to Q, then Q to R. Total distance travelled by you equal to 4 plus 7. Getting or not? 4 plus 7, that is 11 kilometers. But if you will take a displacement, let the straight line distance between P and R, straight line distance, let it is 6 kilometers. 6 kilometers. And the displacement of yours is 6 kilometers. So this is the basic difference between distance and displacement. Always remember the definition of displacement is shortest path between initial point and final point of the object, or shortest distance between initial point and final point of the object, that is called as displacement. Next we will see parting of the zoom, kind master. So another very important point is there, you will find some questions about it also. Always remember, distance can be equal to displacement or more than displacement. Distance can be equal to displacement or more than displacement, not less than the displacement. Always it happens. For example, if you will tell between point A and B, this is the displacement. So if you are traveling along the straight path, then distance will be equal to that displacement, not less than that. It can be more. If you travel in this path, then it can be more. Okay, so this is very important. And another thing here, distance and displacement, already I have told, when you are studying about any physical quantity, distance and displacement both are physical quantity. Already, always remember, when you are studying about any physical quantity, you will remember about some fixed points or fixed things about the physical quantity. First thing is, you will remember about its units. यूनिट्स के बारे में पहले पढ़ेंगे. कोई भी फिजिकल क्वांटिटी जब पढ़ेंगे, यूनिट्स पढ़ेंगे, उसके डेफिनेशन पढ़ेंगे, उसके बाद यूनिट्स पढ़ेंगे. नेक्स्ट यू विल रिमेंबर वेदर इट इज स्केलर और वेक्टर. स्केलर और वेक्टर, that means having direction or not having direction. So if you will tell distance, so distance, what will be the unit? Distance, the standard unit or SI unit, already you have remembered the length. Standard unit of length is meter, so distance unit will be also meter. Displacement, also this is also meter, the same units. But whether scalar or vector, distance is having no direction. Remember, distance is having no direction, so it is scalar. But displacement is having direction, it is vector. You will ask, sir, how displacement is having direction? When you are telling an object is displaced, in English you are telling sentences like this: an object is displaced from this point to this point. So this from and to denotes direction or not? This point is x, this point is y, and the displacement from x to y, so it is direction. Displacement is having direction. That's why it is a vector quantity, or it is having direction. Remember, this is very important. Next we will go to uniform and non-uniform motion. Uniform and non-uniform motion. So many types of motion you are observing in day-to-day life. Always remember, in physics, everything you have observed from your childhood, but due to some lack of concept, or you are a small child, so maximum concept is not there, you cannot explain to yourself. Otherwise, maximum concept you have observed from your childhood. Distance, displacement, everything you have already observed from yourself. Only you have to relate them. You have to relate this concept to your day-to-day life examples or day-to-day life happenings, so that you can get clear about it. So many types of motion you have already studied also in previous classes, like rectilinear motion, curvilinear motion, circular motion, oscillatory motion. That next is revolution, rotation. Many types of motion you have studied. So again here, uniform and non-uniform motion. By taking some example, I will explain it. One object is traveling starting from point A. This is called as origin or point of reference. When you are taking the initial point, always remember with respect to this point you are starting the motion. That's why it is origin, called as origin, or this reference point. An object is starting from point A. Then it is in this direction it is moving. It is going to this point B, then this point C, then this point D. So in this motion, what happens? If you will take your distance and time. This is 0 meter, and at 0 second, this is 0 meter. You can observe here. Next is in 5 seconds the object has covered 5 meter. In next 5 seconds, that is 10 seconds, the object has covered more 5 meter, or that is it is 10 meter from the origin. In next 5 seconds, that means 15 seconds, the object has covered another 5 meter, that is 15 meter. This is one example. Another case we will take the same object starting from point P, then going to Q, then going to R, then going to S. Okay. So here again the same distance, time at 0 second it is 0 meter. Then after 5 seconds, it had traveled 5 meter. After another 5 seconds, that is 10 seconds, it had traveled more 7 meter. Let it be 7 meter, so that it is 12 meter. Another 5 seconds, that is at 15 seconds, if you will see, it has already traveled more 3 meter, not 3 meter, it is longer than that. If you will compare, if you will take it 10, then 22 meter. So here you can observe, first 5 seconds it is covering 5 meter, next 5 seconds, the time interval is same, 5 seconds, 5 seconds, 5 seconds, but the distance covering, it is 5 meter, it is 7 meter, it is 10 meter. So what you are observing here? The time interval is constant, but the distance traveled is different. So here from this example only, you can tell this is in a uniform way, so that this type of motion is uniform motion. This is a non-uniform or irregular way, that's why it is non-uniform. This is the basic, very basic example of uniform and non-uniform motion. If we will go to definition, if we will tell what is the definition of uniform motion, then we will write the motion in which an object travels equal distances in equal time intervals, then the motion is called uniform motion. Okay, clear about it? In non-uniform motion, if the object travels, the motion in which the object travels different distances in equal time interval, that is called as non-uniform motion. The same way you can also tell equal distances in different time interval. You can also tell equal distances in different time interval. So don't be confused about it. Different distances in equal time interval. You can also tell equal distances. Another example you can take, equal distances in different time intervals. That is non-uniform motion. So definition about uniform and non-uniform motion clear. Most important point about this uniform and non-uniform motion is what I am going to tell. You will not find in the book. Actually, in school books it is not written. And in uniform motion, the object is always in a straight line. This must be a straight line motion. Uniform motion, this must be a straight line motion. So conditions are, it must be a straight line motion, and equal distances traveled in equal time interval. So always remember this, add this straight line in the definition. Okay, the motion which is a straight line motion and the object covers equal distances in equal time interval, that is uniform. And non-uniform motion, this can be straight line, either it is straight line or it is curvilinear or rectilinear, that is rectilinear or curvilinear. You will ask, sir, how it is? It may be rectilinear or curvilinear. If I will tell, an object is traveling or covering equal distances in equal time interval, but it is in curvilinear motion. Is it uniform or non-uniform? Always remember, it is non-uniform. If it is traveling in a circular path or in a curved path, but covering equal time, that equal distances in equal time interval, that is non-uniform motion. This is very important point. When you are writing difference between uniform and non-uniform motion, this point you have to add there. Okay, so this is about uniform and non-uniform motion. Okay, next is we will go to speed. Before going to speed, first we will see rate of motion or measuring the rate of motion. So by giving one example, I want to explain here first. You and one of a friend started cycling. You have traveled 10 kilometers in 10 minutes. 10 kilometers in 10 minutes. Your friend had traveled 12 kilometers in 10 minutes. Then who is going fast? Can you tell me who is going fast? Obviously, you will tell, sir, this person, that is my friend, is traveling fast. Because in the same time, 10 minutes and 10 minutes, in 10 minutes I am covering 10 kilometers, whereas my friend is covering in the same time 12 kilometers. So my friend is fast. I am slower than him or her. So here, this is the rate of motion or measuring the rate of motion. In a particular time, what distance you are traveling, that is the rate of motion. So already we have studied, in rate of motion, one word comes, that is speed. From childhood you have studied speed equal to distance by time. Distance by time. Now what does this mean? Speed equal to distance by time. Another example we will take. This is one example. Already you have understood. Person A is covering 60 kilometers. Person A is covering 60 kilometers in 12 hours. Person A is covering 60 kilometers in 12 hours. Person B is covering 100 kilometers. How much? 100 kilometers in 20 hours. Don't take 20, take it 10 hours. Person A is covering 60 kilometers in 50 hours. Person B is covering 100 kilometers in 10 hours. So how you will imagine or how you will find which person or who is faster? So to find this, first what we will do, we will find this person A is covering how much distance in 1 hour. So in 12 hours covering 60. In 1 hour it is covering 60 by 12 equal to 5 kilometers. 5 kilometers. In 1 hour the person B is covering 100 by 10. It is 10 kilometers. So here you can see this person is in 1 hour. In 1 hour. So you are finding here the rate of motion by making the time equal or by taking in 1 hour, and this one is called as unit time. 1 hour, 1 second, 1 minute, these are called as unit time. So you are finding the distance covered by a person or by an object in unit time. So here you can tell this person is faster. So basically this is the speed, and you are finding what you are finding here, the distance, total distance by this time, 60 by 12, and 5 kilometer is 10 kilometer. So this is about speed. Already I have told, after studying about a physical quantity, you will remember about the which type of quantity is which and unit of that quantity. So always remember the speed. Distance was a scalar quantity, so speed is also a scalar quantity. Next is unit of speed. The SI unit of distance is, from this formula you will find the unit. Always remember, when you will find unit, remember the formula so that you can find the unit easily. Distance unit is an SI unit, it is meter, time is second. So SI unit, if you will take, it is meter per second. Other units are also there, that is kilometer per hour, centimeter per second, minute per second, like that you can write. So these are the units of speed. You can see this one in your vehicles, in bike or car, you can see kilometer per hour is written like this, or kmph is written in speedometers. This is kilometer per hour, P for per, kilometer per hour. This is, that is measuring speed, that device is measuring speed. This is about speed. Clear about this? So this rate of motion we have already studied about speed. Next is average speed. Average speed. What is this average speed? Two types of speed are there. One is average speed, another is instantaneous speed. Instantaneous speed. Basically, when we will study, we will always study about average speed. Average speed. Let's take one example. You are starting from your home, going to Bhubaneswar or any other place. You are traveling by a car. At some places, road is not good, so your car speed is very low. If the road is good, car speed is very high. If you are having, you want to take some food, or you want to take some cold drinks, or ऐसे कुछ ऐसे कि सुसु करना है, गाड़ी को रखना है उधर, तो क्या करना है? Different speed you are traveling. After some time you are reaching the point. If I will ask there, what speed you are coming from that point to this place, you cannot tell. So in that case, average speed concept comes. So average speed is basically, if you take the definition, the total distance for total time taken. Total distance covered for total time taken. Average speed equal to total distance. Remember, this is very important. Total distance by total time. Average speed. Take one example. From Keonzhar to Joda. The distance is 200 kilometers. And you have taken time 5 hours. Then the average speed is total distance by total time, that is 200 kilometers by 5 hours. It is 200 divided by 5 is 40. So 40 kilometer per hour. But exactly you have not traveled 40 kilometer per hour throughout the road. Sometimes you have gone by 80 kilometers per hour. Sometimes you are 0 kilometers per hour. Sometimes you are 10 kilometers per hour. But average speed is 40 kilometers per hour. And this formula, remember, if symbolically if you will write this formula, then you would write this V equal to S by T. V equal to S by T. Sir, you will ask me, sir, speed you are taking, it is V. Why this V? Distance you are taking S. Why not D? Time it is T, it is okay, T for time. But remember, another concept is there, velocity. That is similar to this speed, having direction. So due to that, we are taking V here. And why we are taking distance for S? Actually, this is not distance, this is position. Actually, by position we can measure distance. And the S for spatial position. Spatial position करके है, इसलिए first letter S, that's why we are taking S. And T for time is very simple. So V equal to S by T. This is the symbols. Speed symbol is V, distance symbol is S, and time symbol is T. This much you remember. Then next is instantaneous speed. What is instantaneous speed? Speed at the instant time or a particular time. Like the speedometer you can find in your vehicle, sometimes it is showing 10 km per hour, sometimes it is showing 80 km per hour. So that is showing the speed at a particular instant. So its definition is speed at a particular instant is called as instantaneous speed. So speed at a particular instant. This much you remember. Okay. And this is measured by the device speedometer. Speedometer में इसको measure करते हैं. So this is about average speed and instantaneous speed. Unit you have remembered about speed. Whether it is scalar or vector, it is scalar because distance is scalar, and this is the formula symbols. Remember this. And if some problems are coming, then we will solve these problems with this formula. One problem is there in your NCERT book. An object travels 16 meter in 4 seconds, then another 16 meter in 2 seconds. First is that travel 16 meter in 4 seconds, then another 16 meter in 2 seconds. Then what is the average speed? V equal to total distance. Total distance कितना है? 16 plus 16 32 meters. Total time, what is the total time? 4 plus 2 6 seconds. So it is 32 by 6 meter per second. And always remember in this type of fraction you would that make it decimal or mixed fraction. 32 by 6 you will take 32 by 6, it is 5 whole 2 by 6 meter per second. Okay?
16 by 3.
Okay, so 5 whole 2 by 6 meter per second you can write like that, or decimal also you can write. So this is the answer. Always remember this type of question can come. So this is about speed. Next is, we will see, already we have seen, this is velocity. Velocity is nothing but speed with direction. Very simple word you can tell. Speed plus direction. You can write it as velocity. Speed plus direction you can write as velocity. This is very simple. So for example, if you will express velocity of some certain object, how you will express? An object is traveling at 5 km per hour. At 5 km per hour in north direction. This total is called as velocity. Speed plus direction. So here you can see this is the magnitude 5 km and this is the direction. So velocity is a vector quantity. And the units are same as speed. Kilometer per hour, meter per second, that minute per second, centimeter per second, same. In velocity, we will read one concept, that is average velocity. Everywhere in this chapter, we will come in concept, or we will come through. We will study this average velocity. If some variable velocities are there, let take one example. When an object is getting started. It is starting, going to start its motion from this point A. At this point and ending its motion at B. At this point, time is 0 as well as the velocity or speed is 0. That velocity is called as initial velocity. When you are taking the time into consideration at first, okay, when you will take the time at first, that at that time the velocity is called as initial velocity, and when you are taking that is taking that, it is now I will take this time as ending time, that is the final velocity. Initial velocity and final velocity. If object having variable velocities in between 2 points, let it is starting from 0 km per hour to 60 km per hour. 60 km per hour. That means the velocity is getting increased from 0 to 60. Suddenly, ऐसा तो नहीं होता है. Suddenly 0 to 60, it is getting increased from 0 to 60. So, at how many times you are observing? First is initial, second is final. Okay, so 2 times you are observing. This is initial and this is final. So, average velocity equal to sum of all the velocities by time of observation. But here we can write directly according to your book or NCERT, a very simple concept. Initial velocity plus final velocity. We have told average by 2. How many times? 2 times you are considering, that's right, 2. Initial velocity plus final velocity by 2. If in symbolically, if you will represent this one, average velocity equal to initial velocity plus final velocity, you will write V for velocity, average equal to initial velocity. Always remember, we take it V0 plus final velocity is sorry. V average equal to U plus V. U is taken as initial velocity, V is taken as final velocity by 2. Remember this. It is very important. Initial velocity plus final velocity by 2. Okay? So this is about average velocity. So in your book related to this concept, some questions are given, very basic questions. See, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So, if an object is having covering some distance, already I have told distance can be equal or more than displacement. So displacement will be less. Displacement can be less than the distance. So in this, take one example of circular motion. If the object is starting from here in the circular motion, then you can see here the object is starting covering some distance, but the displacement is 0. So in a circular loop or this type of path, if the object is covering, it is having some distance, but displacement is 0. So there is a question related to displacement. You can see here, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. Side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So, in this question, first what we will do? First, understand the question properly. Understanding question properly equal to 50% answer solved. So, first it is about a square. So, we will draw one square first. Let this be the A, B, C, D. And from initial position, let this A will be A as the initial position. And about the square, what is given? The sides are 10 meter. This is 10 meter, this is 10 meter, this is also 10 meter, this is also 10 meter. So from here you can find the perimeter of square equal to 40 meter. 4 into 10, it is 40 meter. Means So the farmer is starting from here and making or traveling through the square and coming again to the A. It is covering 40 meter. In one round, it is covering 40 meter. So next question, and what is the time taken? Time equal to 40 seconds. So he is traveling 40 meter in 40 seconds. Question is, what will be the magnitude of displacement of the farmer at the end of 2 minutes and 20 seconds from his initial position? So this given time is 2 minutes 20 seconds. Always remember, when time or any quantity is given in different unit, according to your convenience, you convert the unit first. 2 minutes 20 seconds is 2 into 60 plus 20 equal to 80 plus 20, it is 100 seconds.
120 plus 20. ठीक है 140 seconds.
काटे हुए
नहीं
2 into 60 it is 120 plus 20, it is 140 seconds. So this is 140 seconds. So at the end of 140 seconds from his initial position, what will be the displacement, total displacement? So here you see, in 40 seconds he is making one round and covering 40 meter. So every 40 seconds his distance covered is 40 meter, but displacement is 0. So every 40 seconds the displacement is 0. So if you will take 140 seconds, in 140 seconds, how many 40 seconds will come? That is 140 divided by 40. 40 3 is 120 and minus it is 20. Okay, so you are finding the remainder 20. Means 3 times he is doing the revolution around the field and 3 times he is making the displacement 0. Then another 20 meter, after traveling another 20 meter, what will be the displacement we have to find. So another 20 seconds. Sorry, another 20 seconds. So here you can see these 10 meter is taken 10 seconds. These 10 meter taken 10 seconds. So 20 seconds traveling from A to C. This is the point where it is starting. C. Final point is C in 20 seconds. So what is the displacement? Always remember, displacement is the straight line distance between 2 points, that is from A to C. This is the straight line distance. And how to calculate this length? In mathematics already we have studied. In square it is 90 degree, as it is a right angle triangle. By Pythagoras theorem you can find. So this length equal to AC equal to AB square, that is AB square plus BC square root over. This is 10 meter, 10 square plus 10 square root over. This is 100 plus 100, it is 200 root over. 200 root over. You can find here 2 into 100. So it is 10 root 2
14.2.
10 root 2 meter. Unit is meter. So this AC equal to 10 root 2. So this is 10 root 2 meter. So displacement is 10 root 2 meter. Got it? Okay. Stop. Another question is there which is related to speed and velocity. It is in NCERT book. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? Where it is given speed of signal equal to, it is almost equal to the light, that is speed of light, that is 3 into 10 to the power 8 meters per second. So here what is given? What is asked? Distance is asked. What is given? You can see here the time to reach. Time is given. Speed is given. Speed of the signal is given. It is asked what is the distance of the spaceship from the ground station. So already we have studied about the formula. Speed equal to this very basic formula, distance by time. So as speed is given, and time is given. You have to find the distance. We can write distance equal to speed into time. Remember this very carefully from this formula. Distance equal to speed into time. So speed is given and time is given. As speed equal to, first you will write given speed equal to speed of signal equal to 3 into 10 to 8 meter per second. Time equal to 5 minutes. 5 minutes. As you can see here in speed, second unit time of that unit of time is given as second, but here minute is given, so you have to convert it into second. 5 into 60 second, so that it is 300 seconds. Now you can put these two values, speed equal to 3 into 10 to the power 8 meter per second into time equal to 300 seconds. So as you can solve this, 3 into 3 it is 9, 10 to the 8, another 2 zeros, so you can write 10 to the power 10 meter per second second. This you can see the distance unit is coming here, meter. 9 into 10 to the power 10 meters. This is the answer. So already we have finished in this chapter rest and motion, uniform non-uniform motion, speed, velocity, average speed, average velocity. So you go through your book. Reading, book reading is must. Whenever you are studying physics or any subject, book reading is must. And you, whatever I have taught in NCERT book, you read it properly, and the question related to this concept, you do it in a copy. And if there is any doubt about this concept, please post it in comment. And if those who are not having NCERT book, I will give the link in the below the video. You can find NCERT book link from there about this chapter. Thank you. Next video we will have acceleration and graphs. Okay, bye.